In this video, we want to look at how to integrate functions from the first principle. That is, integration of functions from the first principle. Let's consider an example. Suppose we want to integrate function f of x is equal to x under the interval, or let's say from 0 to 1, using integration by first principle. So we want to integrate using first principle approach. Now, you can recall in calculus, there is something we call differentiation from the first principle. So also we have integration, by first principle. So let's look at this interval given to us. The interval given to us is between 0 and 1. So the interval has the endpoints 0 and 1. So 0 and 1 are involved. They are included. So it's just like saying that suppose we have, this is a real line, we have 0, we have 1 here. Now we can partition this interval into n segments by saying that, let's say we have 1, 2, 3, 4, 5. So our n here is 5. So the first point here will be x0, while the last point here will be x5, which is xn. That is x1, x2, x3, x4, x5. So each of these intervals are sub-intervals. As you can see, they are sub-intervals. Right. So now, the very first thing we are going to do now is to find the length of the interval. And we know the length of the interval is just the difference between the upper limit and the lower limit. So the length, let's designate that as change in x, which is what? 1 minus 0. Now, because we are partitioning now, that means we are going to divide the length into n segments. So let's put all over n, which is 1 all over n. Mind you, the 5 I use here is an example, it's an illustration. This should be xn, okay? I just use that n as 5 as an example. Now, let's pick from the left endpoint. From the left endpoint, we have our xi will be equals to I all over n. Remember? Why picking high? Fine. I can have my xi here where I is 0. So if my xi here, I is n. So we are starting from the left end here. So I all over n. Beautiful. Now, according to Riemann integration, you can remember Riemann, a very great reanalysis experts, by Riemann integration, the integral of a function, say f of x dx, running from interval, let's say a to b, is equal to the summation, as you can remember, f of xi change in x, and our I is moving from 0 to n minus 1. Okay? So with that, we just need to do some substitution. Let's check. Let's do some substitution. So we're going to have, that implies that, and don't forget the limit of this summation will be so I could have written the limit, let me put it this way there, then that is the integral of f of x dx from limit a to b, is equal to the limit as n tends to infinity of the summation of f of xi change in x. Remember, our I is moving from 0 to n minus 1. Beautiful. So that means by substitution, so we have, so we can have, this implies that we have what? Let's find the summation before we take our limits, or we can do it directly. Okay, limits as n tends to infinity over summation, f of xi, our x, our x is x, our xi will xi, and our xi is a I all over n. Our I is moving from 0 to n minus 1, multiplied by change in x, that is what? Our change in x is what? Is 1 all over n that we have gotten before. So that will give us what? The limits as n tends to infinity, by the time you bring this on here, you're going to have what? Summation, putting this one there, the constant, 1 all over n squared, yes, 1 times I is I, then I, n times n is this. I hope you understand that. I moving from 0 to n minus 1. So let's deal with the summation first. Before we now take our limits. Okay? Recall summation xi is equal to, that is, I is what? The nth numbers. Let's say if I say I is moving from 1 to n, I'll be having what? N into n plus 1 all over 2 by mathematical induction. That is the summation of the first n natural numbers. But in this case now, our high is moving from 0 to n minus 1. So that means our n is n minus 1, which implies that therefore summation I moving from 0 to n minus 1 will be equal to, n is now n minus 1. N minus 1 into brackets, n minus 1 plus 1 all over 2. Beautiful. So that will give us what? That will give us n minus 1. That will give us n minus 1 into n all over 2. How we get that? Because minus 1 plus 1 will cancel. Beautiful. So now with this, you now take the what? You now take the limits. You now take the limits. We now take the limits. We now take the limits. I think there's no problem here. Beautiful. There's no problem here. Okay. So now that we have gotten that, we have gotten our summation. Our summation I moving from 0 to n minus 1 is now what? N into n minus 1 all over 2. And recall what we are looking for is, what we are looking for is 1 all over n squared summation I move from 0 to what? To n minus 1, which is not what? 1 all over n squared multiplied by the summation this now is n into n minus 1 all over 2. So the n here we cancel out this. So we have what left? We having n minus 1 all over 2n. Beautiful. So we're having what? N minus 1 all over 2n. So that implies now, using the Riemann integration, we have the limits as n tends to infinity of n minus 1 all over 2n. Now, looking at the numerator and denominator, n, we have n here, so we can divide the numerator and denominator by n. So that will be n all over n minus 1 over n in all over 2n all over n. Okay? So, by the time we divide the numerator and denominator through by n, we're going to have what? We're having 1 minus 1 all over n all over 2. Okay? So, with limits now, n tends to infinity of this. That will be what? 1 minus 0, because 1 over infinity is 0, all over 2. So the result is what? 1 all over 2. So our result will be 1 all over 2. So that means if we integrate the function f of x is equal to x from the limit 0 to 1, we're going to get half. Let's check that. Let's check whether we get it right or not. We can check using the normal calculus method. Let's check. Using the normal calculus method, let's try to check. Okay, we check now. Check the integral of x dx moving from 0 to 1. So if we integrate x, we have x squared all over 2. So putting the limit there, 0 and 1, that will be what? When x is 1, that is 1 squared all over 2 minus when x is 0, 0 squared all over 2. So that will be what? 1 all over 2 minus 0, which is half. So we are correct. So this is how the result is obtained. So do well here to click the notification bell so that each time I upload a video, you'll be duly notified. Thank you.